We're now going to find the confidence interval for this problem. Remember that in order to find the confidence interval, we need Q1 hat and we need 2Q hat. We need those two things to find the confidence interval, to build the confidence interval. So I'm just going to do 1 minus P1 hat. Oops. What is happening? 1 minus 0.112903226 is 0.8870967774. And Q2 hat is going to be 1 minus 0.143137255, which is 0.8568627745. Okay, let's be very, very careful about building the appropriate confidence interval now. We're now going to construct the confidence level, and they don't give us a value for the significance level, so I'm going to assume that we're going to keep using the significance level of 0.05. So a 0.05 confidence interval is 2-tail, which is a value of 1.96. Okay, so 1.96 is 5% confidence interval. So the z alpha over 2 is going to be 1.96. Okay? So let's go ahead and remember back to what our formula was for the confidence interval, which I wrote down on the previous page. I'm not going to write it again, but this is the formula right here we're going to be following. And so here we go. This is where you just got to be really careful with your calculator. We start by doing the two proportions subtracting each other, so 0.1129, 0.3226 minus 0.143137255 minus, and now we do our critical value, which is 1.96, and then that's times this humongous square root, where we do p hat times q hat divided by n plus p hat q hat divided by n for the second sample. So 0.1129, 0.3226 times 0.143137255 divided by our first sample size, which was 248, and then it's just plus 0.143137255 times 0.856862745 divided by our second sample size, which was 510. Oh, you know what they did? I think we have the right answer, but I just noticed that in my notes, it doesn't say it here, but in my notes, they said that they want a 90% confidence interval. So I didn't list that here, but in my notes, they said that they want a 90%. I think it's really dumb that they change it every single time for even within the same problem. So I don't know why they do that. But luckily, all I have to do is just change my test statistic. So, I mean my critical value. So they wanted 90%. So we're going to go to 90% two-tail, which is 1.645. So just be really careful. I don't know why they change it so much. It won't even let me put it in. Because there's too many numbers. Wow, I don't know what to do now. Let's try changing that to 1.65 and see what happens. For some reason, I'm not getting the answer that they're getting. So I'm going to pause the video and try to find out why that is.